Hey everyone, this is Emmanuel from AirTrain. So today I want to talk about a new open source large language model that came out a couple weeks ago called Mistral 7B. It was released by a French company called Mistral AI. And so the model is a large model, but it's much smaller than other models that have been released recently. It's only 7.3 billion parameters, so much smaller than your Llama 2s and your Falcons out there. And it has a 8,000 token context length. What's interesting about this model is that one of the things that are interesting about this model is that it's licensed under the Apache 2.0 license, which means that it's allowed for commercial use. Also, they mention on the Mistral AI website that this is a tease. So this is just like the first model that they're putting out, and they're probably working on a bigger model. But already this small model, small 7B, has a really good performance. So here they compare Mistral 7B to the Llama family of models, so Llama 2 and Llama 1. And as you can see on a number of benchmarks, the Mistral performs a lot better. So for example, MMLU, which is a general knowledge, we'll get more into that later, but it's a general knowledge benchmark. It performs much better than those other two models, other models here. So that's pretty impressive for such a small model. So we don't really know what data set it was trained on. They don't really disclose it in the paper, but they do disclose two things that went into the model. The first is that they used a sliding window attention. So the idea is that when you create the attention matrix, so basically the dependencies between the attention that each token gives to other tokens in the sequence, if you retain all of the past tokens from the sequence, then your memory grows dramatically and it becomes really difficult to inference for large sequences. So for example, here we have what they call vanilla attention, which is sometimes called dense attention, where they keep the weights for all the previous tokens in the sequence, which can become very sort of cumbersome for very long sequences. So if you're trying to do inference on long text, then it's kind of problematic. So what they do instead is they use a sliding window attention. So they only keep the weights for the last few tokens, and then they purge the older tokens. So that doesn't mean that they lose the attention for all the tokens, because remember, this is multiple layers of transformers, as you can see here on the right side, which means that you still retain some attention for all the tokens. So for example, they say here at the last layer of the model, using a window size of 4,096 token, they have a theoretical attention span of 131,000 tokens. So you don't forget the sort of the beginning of the sequence, but it makes for much more performant inference. So that means that it's much faster to do inference. It uses a constant amount of memory, doesn't grow with the sequence length. So that's good news for performance. So that's one thing they use, sliding window attention. This seems to become a common pattern in new models to use this technique. Another technique that they use is what they call group query attention. The idea is that in the regular attention mechanism, each token in the input sequence results into a query. So you multiply the token embedding by the query weights and you get a query. And then you have the lookup keys that are also one per query. So you can see the multi-head here. That means that there's a lot of keys and values to keep track of. And so instead they group a certain number of queries to be able to keep fewer keys and values. So they also reduce memory usage. And if you do this correctly, you don't lose too much performance. So they use those two mechanisms, sliding window attention and group query attention, to reduce the amount of compute that they need to produce the model. So let's go back and take a look at evaluation. MMLU, as I said, is a general knowledge evaluation framework. So here's the paper, and essentially it's a test that covers 57 tasks, including things like math, US history, computer science, law, and so on. So it's a good benchmark to see how the model performs on a wide variety of topics. As you can see on this general benchmark, it's really good, and compared to the Llama models, including Llama 213b. So that's pretty impressive. Another benchmark they use is GSM 8K. So that's essentially a data set of high school level math problems. Here's how the model performs on that. Math, so as you can see, Mistral 7B performs much better than the Llama family of model on those kind of high school math. So this is pretty impressive for such a small model, which holds a lot of promise for the next model. This is supposed to be a tease model, so it's pretty impressive what they can already do with that. It's interesting they use this comparison method here, where they try to find the equivalent model size to have similar performance in the Llama 2 family. So for example, here they say that on the MMLU benchmark, to have similar performance to the Mistral model, you would need to have a 23 billion parameter size Llama model to have equivalent performance. So that's an interesting way of comparing models. So the model is available on Hugging Face for anybody to use, and there's already a number of fine tunings available. One of them is directly made by Mistral themselves. So they fine-tuned on a number of public datasets. Again, they don't say which ones, and it performs really well to do chat. Another one is the OpenOrca fine-tuning that seems to be pretty popular. So OpenOrca essentially is a fine-tuning that is based on the OpenOrca dataset. So the OpenOrca dataset is a very finely curated dataset. Here it is on Hugging Face. Let me make this a little bigger. And essentially, it's a data set that tries to break down reasoning really granularly. So for each question, each prompt, you have a really detailed answer with like step-by-step reasoning. That's a great way to teach the model to reason very precisely and granularly and give really detailed answers. As you can see down here, it performs really well. It really outperforms all the 13 billion parameter models that you can see here, all the 7 billion models as well. So that's quite impressive for a 7 billion parameter model. And so this fine-tuning is out there on Hugging Face as well. To conclude, this shows you how you can really get some really good performance for smaller models, smaller 7B instead of like, you know, your 180B from Falcon, for example, and even better if you fine-tune with high-quality data sets. I'm super excited to see what Mistral AI comes up with next, so maybe an even better model. Thank you so much for watching. Don't forget to subscribe and check us out at airtrain.ai. And that's it. Thank you so much. Bye-bye.